You guys hear me? Good morning. I am glad. Let's see. Good morning. Let me see. I'm just getting quickly everything ready. I had some network trouble, so I'm gonna start just now. All right. Let me just. Open the capital budgeting. Let's see. All right, I'm gonna share my screen and then you just keep me informed if anything happens. Do this. You can just keep my webcam off just in case it makes it worse. So there we go. Can you guys see my slideshow? Thank you. Let me start from the beginning and let's see how that goes. You guys can hear me loud and clear, right? There's a very big storm here with us, so. Okay, cool. Thank you. Yeah, Stellenbosch is still underwater, so we're just surviving to the side. Let me see. Oh, thank you. I'm safe in the office. It just sounds very horrible, you know. Yeah, it does. Yeah, I also love hearing it, but driving in it, not so fun though. Yeah, I also like listening to it, but yeah, driving in it that's the problem. Yeah, that's true. Getting your anger out while you're driving. That's one way. So I take it, Armandra, you are someone who has a little bit of road rage, I guess. Yeah, that's all you need. That's all. Okay, let's continue. Okay, so tomorrow is your first test. Again, just reiterating that if the dates for the other test that is on the second moves, I'll let you know. I haven't gotten any confirmation on that yet, but otherwise, study guide is telling you when what. So tomorrow is our first test. Just to remind you, remember your webcam has to be on, otherwise an incident will be reported. So please make sure you don't have any trouble before tomorrow. Don't struggle tomorrow and then you waste time because the test closes after the amount allocated to it. Right, so please make sure before tomorrow. Don't waste time in the test tomorrow with a webcam that's not on. Okay, so please switch it on from the beginning, join Hypeflex. Even if I'm not here, have your webcam on. If something happens, I'm sure Ms. Reiners will help or someone else will help. But please be on with your webcam, go on assessment queue, relax, have a paper, blank paper, of course, so you can write down. If you need a calculator, have that ready. Be ready beforehand so you don't stress. 8 o'clock, then you start. Okay. hope so. So let's see how today goes, and then let's hope it's going to go well. But yeah, if you attended, you listened, and you practiced, obviously the practice part is very important. You'll be more than okay. Okay. But practicing is very important because that will help you go faster and you'll be able to actually finish and do every single question. But remember my advice, when you open that test, begin with what you know you can do fast so that you can have time on other questions that you are maybe a bit slower on. Okay, try to fill in as much as possible. That's what I'm trying to say. All right, there's no upload, so try to fill in as much as possible and check the instructions you know by now. Don't lose a mark because you didn't read the instruction. Please read the instruction. All right. Oh, thank you, Armandre. That is perfect. Let me do that quickly now so that I know we've got that sorted. So I'm just going to open the answers for the practice questions that I gave as extra. And no mock test, I already gave extra practice questions. So I'm just going to quickly go open the answers there so that you can work through it. If there's something, remember, like let's say you don't agree, just check with Solver, and yeah, Solver will definitely give you the right answer there. So then you are definitely sure. Right. So I'm just going to quickly go and open that. Yes, mock test on the assessment queue was just to get you guys used to the system. You guys have been in the system. So I'm sorry. It's now just extra questions. Now it's part of it. Let me see. Okay, these are the questions. I'm just going to quickly open the answers. So it's in an Excel sheet that you will download. And there we go. It should be open. All right. Okay, so the answers should also now be open on BC Connect. Those practice questions. No, I have already said that I don't know about the second yet. I'll let you know as soon as I know. Right. In a sense, Armando, yes, you'll be fine. Of course, there's some logical stuff that, like, I can prepare you as much as possible, and the exercises can prepare you, but sometimes the questions are in that moment. You have to show us your logic. So you'll be fine, but whether or not you'll get a distinction or not, that's now up to you. Okay. So just to say you'll be fine, but I'm hoping for more. Okay. So let's get to capital budgeting to show you the idea of capital budgeting, and then we're going to go on to an exercise there so that you can see what it's about. But capital budgeting is basically about having certain inputs that you are evaluating against each other. So you have, in this case, or this scenario, it doesn't have to be investments, but in this scenario, you have investments. So you have certain inputs that you are evaluating against each other and then deciding which ones to take. Right, so for example, in this case, we are looking at 4 investments, and the company wants to know which investments to actually invest in. Right, so you'll see in the decision variable, it's either investing or not. Right, so in this case, we don't have Xij like we did before because there's no need to identify, for example, investment 2 for person 2 or investment 2 for business 2. it's purely just I've got different investments with their own values, and that's it. So it's not a value specifically for an investment and something else. So it's not like a matrix form. So it's either the investment is actually invested in or not. We have 4 investments, so your I is going to be from 1 to 4. Now you've got net present values that will actually tell you what worth these investments will give. So you'll see the, for example, investment 1 as a value of 16,000, 2, 22,000, 3, 12,000, and 4, 8,000. Then if you read further, they say, what will the outflow be? So that we'll get to very soon. But even if I don't specify what to formulate about, you can then go technically 2 routes where you can decide, are you going to maximize the value of the investments, or are you going to minimize the outflow of the values? Now, determining which one to go with is to check what is going to be the constraint, because that will not be your objective. Okay, so let's check what would be the constraint before I read further on. You'll see there later on, currently 14,000 is available for the investment. So what is this 14,000 referring to? Is it referring to the net present value that you'll get or the cash outflow? What do you guys think? What's this 14,000 for? Because it is for investing, but is it for the net present values or is it for the cash outflow? Very good, the cash outflow, because that is telling you how much you are going to spend on that investment before you get a net present value. Right, so you have a limitation on your cash outflows to say how much is it going to cost you for these investments. So you're going to have a constraint specifically for, so I'll write there, outflow. So that means our objective function will then be the opposite one, in this case, the net present value. And if you want to work with the worth in your objective, you probably want to get the best out of the value, right? The best worth from your investments. So we're going to maximize. Although I'm just saying that just in case something was not specified. But in this case, they did actually say maximize the NPV. So just wanted to make clear if it's not specified. Right, but what's the NPV? You've got your values for your different investments. And you'll see there you can divide by 1,000, but please, when you're done and you get your Z value, you have to then multiply the 1,000 back in. All right, so if you decide to divide by something for that objective function, at the end, you have to multiply it back in to have the correct Z value. All right, the X values will be the X values, but the Z value, you need to then multiply back. All right. Okay, then you're just putting the values where they are supposed to be. So I'm not going to go into that. Lastly, we say it's binary because either the company is going to invest or not. So it's binary. Now, remember, you can solve this with branch and bound simplex, where you relax the IP and then solve it as if it's a normal LP. And then once you get a solution and there are decimals, you then go and say, okay, let me use branch and bound simplex or cut and plain to get binary values, 0 or 1. Just to remind you, before you do that, add constraints in to make sure your answers for your variables, each variable, that they are limited to not go past 1, right? So that you are already in a range of between 0 and 1, so that when you branch and bound, you literally just go either 0 or 1, right? You still do the less than and greater than, but it's just between 0 and 1 constantly. Otherwise, you're going to work with a lot bigger branches to first get to less than, less than, less than. Okay. Then, on a different note, you can't use Hungarian. Why not? Who knows? Why can't I use the Hungarian algorithm for something like this? Yeah, there's no matrix, there's no square matrix, so there's nothing you can do. Right, if you had, let's say, investments per branch or something, let's say you had a branch 1 and a branch 2, and investment 1, 2, and you want to know, okay, can I do this one, or can I do this one and this one? Then it becomes a square or just a matrix that you can start with. Remember, you can add dummy investments if you had more, but it's a matrix nonetheless. Then you can work with it. In this case, we didn't have something like that. It's either it's invested in the company stocks and bonds or not. All right. So let's go on. Now I've got some extra constraints to help you with what capital budgeting will normally include. Right, so there will probably be some limitations. So now we get to your binary constraints. So if you struggle, your heading will then be binary constraints that you can go look up for some videos or something to help you. I think I also posted some videos, but can't remember. On BC Connect, I shared links for some concepts, especially constraints. Right, so you can go and look up then binary constraints or logical constraints to help you with these constraints that you have to set up yourself. Okay, let's have a look. So right now, if I check the first requirement that they give us, they say, first of all, modify the formulation to account the following requirements. And the first requirement is to make sure stocks and bonds can invest in at most 2 investments. So if I go back here, I go and check, but how can I see my investments in terms of binary? Because that will tell me how many investments were invested in. Because binary is either 1 or 0. So if I add all of them up, it's going to technically count up how many. But where do I see that? Luckily, in this example, there's no other variables. So it's literally just in my X variables. It is binary. So just to make it clear, guys, we're going to get some examples later on or IPs later on where it's not going to be just one variable. So you can have one variable that is binary and you can have maybe a y that is integer. So then you go and say, if I want to count up how many investments, then I go to the one where it's binary to say, okay, I can see, is it invested? Yes. Is it invested? Yes. So if 1 is 0, it's not invested, so skip that one. Is this one invested? Yes. And then you sum that up, you're going to get the actual total investments. So just to make it clear. All right, so we say, okay, in this case, it's obvious it is our X variables. Which X variables? They're saying we want to make sure that we have at most 2 investments. So I don't know which investments, just to make it very clear. I'm not solving, I'm creating an IP that I can use to solve. So don't tell me, oh, but is this one? No, that's not the point. What if I've got 10 investments? Are you really going to try and do that in your head? So the idea is to set up constraints to make this possible, and what should not be possible, we should decline or constrain. So we go and say, okay, we've got X1, X4, X2 up until, so I'm going to write it out, up until X4 because there are 4 investments. And I'm going to literally, because they're saying at most, I'm going to literally restrict it to be at most, so less than or equals to 2. So at most, meaning you can't have more than 2. So why will this work? If I go and put some ones and zeros, if I say investment 1 is invested in and investment 3 is invested in, will it make sure that that is true? Will that be true? Yes, and that's what we want so far. They said at most 2. So 1 plus 1 is going to be then giving you 2. So that's perfectly fine. That's allowed. Will something like this be fine? Will that be true? Should it be true? Let's see if you guys can answer that. Should it be true? If it's true, should it be? So should this be allowed? Yes, 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 yes. He said at most 2, so you can have 1 or 0 as well. Just at most should be 2. Yes, 2 is the cap. So at most 2. Right, so this should be fine. That's perfect. So even 0 plus 0, Rishkar, that's the requirement that we're adding. So if we add 0 and 0 and 0, no problem, 0, that should also be true, is it? Yes, because 0 plus 0 plus 0 plus 0 is 0, and 0 less than or equal to 2 is in fact true. It's allowing that to happen. Now, if I go and say 1 plus 1 plus 1 plus 0, should that be allowed? No, because we said at most 2. Is it allowing it? No, very good. Because 3 is not less than or equal to 2. So if it's false, it's not going to be allowed. So that's not going to be possible. Not possible. So we added the constraint to make sure that that is actually not going to be possible. Right, and that is exactly what should not be possible. So with binary constraints, you have to think of all the different conditions, and you have to make sure that what is supposed to be possible is true. It's going to give you true answers. And what is going to be not possible, or what is supposed to be not possible, should give you false answers. Okay. So if we go here, let's go to the second example. So this one gets a bit more tricky to do. Let me just open Paint there and give myself some space. Why is it now? That would do. Okay, so the second example is talking about, so this is number 2, the second constraint we have to add. If stocks and bonds invest in investment 2, they must also invest in investment 1. Now, first off, go back to your decision variables and take note which one is investment 2 and which one is investment 1 in terms of your variables. And you're dealing with the fact that if they do this, they must do this. So the if tells you that I'm probably going to have to do some conditional checking, right? And if you just think about it, we're asking if they invest, and they must also invest. So we're checking if they actually invest. So meaning binary, meaning is it a 1? Then the other one should also be a 1. So I'm only looking at variables right now that are actually binary, right? Which is the only variables we have, but that's the idea. So going back here, which X is for investment 2? Who can tell me? Which X variables am I referring to if I say investment 2? X2, perfect. And investment 4? Perfect. So we can immediately see that our X's represent which investment. Okay, so let's go back here. They're talking about investment 2 and investment 1. You could have written 1 first and then 2, as long as you make sure whatever works, works. Okay. Now, with these constraints, you can do anything as long as you keep it linear, because we're so busy with linear programming. Okay. So you have to keep it linear, meaning don't go and multiply a variable with a variable. Okay. You can multiply for any value. You can divide by any value. You can divide by any value. You can add or subtract the variables, not multiply, but you can add or subtract the variables. You can add any sign, any value, but it needs to meet all the conditions. So you're going to have to check what should be true and what should be false. Let's just hope I'm not working too slow. So let's see. So we're saying if they invest in X2, then must, why did the N not go? Then must, so I'm not going to write it full, but then must invest in investment 1. Okay. So that's our concept. Now let's first see what should be possible and what should not be possible. Remember, you have to check all conditions. So you're going to do now a bit of combinations, right, to see what can it possibly be, and then identify what should be allowed. So those will be true. So remember, allowing something, you want true. And then restricting or not allowing something, you're going to want it to be false. Okay. So if we start, we say, okay, if they invest, so let's start with the most obvious one. If they invest in this one, it's going to be a 1 because then they invest. And then they invest in this one. Should that be true? Sharp, true, T. So you guys can from now on just give me a T and an F. Okay. So yes, true. So we write true. We're ready. We want that to be true. What about this? Investment 2, but not investment 1. F for false. We want investment 2 and 1 if it's 2. Remember, the keyword is if. If they invest in 2, then they must invest in 1. So if it's 2 and not 1, so 0 for x1, not 1, then that should be false. Should be. Should be. What about this? Now be careful before you answer. So this should be actually true. Right, so true, reason being, they only said if x2. They never said something about if x2 does not get invested in. So we can't restrict it if x2 is actually not invested in, because they never said anything about that. They specifically wanted the if to handle it if x2 is invested in, then x1. But they never said what if x2 is not invested in. So do not restrict too much. This should be allowed because they never said it's not possible. Or logically speaking, it should still be, should actually still be available, right? So true. So now, based on what I just said, should this be allowed? True, false? True, yes, true, 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 because I never said what if x2 is not invested. The whole purpose was to make sure that if x2 is invested, then x1 must also. But you don't restrict anything else. Okay, so also true. But how do we make a constraint for this? Now that's the question. Okay. Now, first off, I always recommend starting with in the middle of the 2 variables. If you have 3 variables, then unfortunately you can't, that's not as simple as that. But with 2 variables, you start in the middle and you first check, can you simply just use one of these to make this happen? All of your conditions must be met. All conditions, I'm just going to say conditions, must be met. And I'm talking about the true, false, true, true. If it must be true, then your constraint needs to allow it to be true. Okay, so let's see. If that doesn't work, guys, then you're going to go and say, okay, I'm either going to use a plus or a minus in the middle of these, and then have right-hand side values with one of those. So I'm just making clear that if that fails to happen, so if you have more constraints, and you might need to play around with multiplying one of these by something or divide by something. So those are your options. All right, but we're going to start with the middle. So if I make, just to make it clear, guys, if I put a less than or equals to in the middle of them, it has to be for all of them, because you're not going to create 4 different constraints. That will not work, and it's very inefficient. If you get something to work, it's going to take very, very long to get that answer. Right, so you're creating one single constraint to make all of this happen. One single, meaning it needs to have whatever you put in the middle is going to be for all of them, because it's a single constraint. Whatever you put as a right-hand side needs to be for all of them, literally. Right, because when you're done, you're going to create the single constraint with whatever you wrote for all of them. Okay, so just to make it clear. So I'm starting with less than or equals to, meaning all of them are going to be less than or equals to. But let's see if it would work. If I say 1 less than or equals to 1, is that true or false? True. Should it be? Yes, that one is met. Next one. Is 1 less than or equals to 0 true or false? Should it be? Yes, I smile. I started with something that was too obvious. But anyway, the next one. Is 0 less than or equals to 1 true or false? True. Should it be? Yeah, Evan is like very quickly. Yes. Next one. Is it true or false? True. Should it be? Yes. So it meets all my conditions. Literally all of them, guys. You have to play around to make sure you've got all the combinations in terms of ones and zeros, which we do have. We have 1, 1, 1, 0, 0, 1, and 0, 0, all the combinations. We met all of them, so we can write a constraint. So we can write our constraint as, who can guess? Evan, yes, it will. So who can write a constraint for me based on what we just did? x2 less than or equals to x1. Perfect. Just, yes, like Andre showed there, just make sure you write it in standard form, especially for tests, and especially for simplex. I mean, you can't solve that in solver or simplex. So we go minus x1, we bring it over, plus x2 less than or equals to 0. And that's your final constraint. And there we go. Yes, you will have to manually go through each possible option. Yes, that's what these constraints are about, definitely. I'm going to just start this constraint again, but by swapping x1 and x2, so that you can see the process of what if it didn't work now. All right, so you just can see the process if I start with the wrong sign, just to give you a bit of a heads up there. So we're going to do exactly the same, just swapping x1 and x2, just to make it very clear. Let's use this. If you want to take a picture before I erase, quickly do that. I don't do it, but it is in the slides, but some of you might want to use that. And Andipa, I just took x1 to the left, and then nothing's left over on the right-hand side. So it's literally then 0 that is left over on the right-hand side. Just to put it in standard form, remember all your variables must be on the left and your constants on the right. So when you take it to the left and there's nothing left over, it stays 0 then. Okay. Okay. So let me erase. I'm sure we can do it the other way around. Let me do this. So instead of this, I'm going to say let's work with x1 and x2, because normally you would start in an actual order so that, how can I say, when you put it in a constraint, it's easier. But I want to show you that the constraints are, it looks different, but it's exactly the same. So there's sometimes more than one option. So when you review your test, please, we'll make announcements when you need to review and who to contact. But when you review the test, please check that yours is maybe not correct in terms of just by dividing by -1 and swapping the sign. Because you'll see now it's going to be exactly the same, we're just starting different, so it swaps our sign with dividing by -1. So just to make clear, guys, if you have a sign and you divide by -1, that sign will swap. Okay, so I'll show you now what I mean with that. Okay, so we're swapping them around and we're starting now with, again, okay, should this, let me just write it like this. Let's do it again for those of you who are probably sitting there like, what is she doing? So let's start again. Should this be allowed? Should it be true or false? True, yes, because we're saying if x2, so meaning if x2 is 1, then x1 must also be 1. So that definitely must be true. I have to have it as true. Should this be true? Be careful. True or false? Be very careful now. If x2, then must x1, but they never say what should happen if x2 is not invested in, so we can't say false there. It should be allowed, right? x2 is restricted if it is actually invested in. Yes, very good. x2 is restricted if you invest in. But if you don't invest in it, it's not restricted. It's only x1. So that should be true, yes. True. So we're just working the other way around to say, if x1 is invested, does x2 need to be invested? No, that's not what they said should happen. They just said if x2 is invested, then x1 must be invested. But they never said that this is not okay. They never said it's not okay to invest in 1 and not in 2. Right, so that we should allow. Remember, you can't restrict too much because then you're restricting things that are actually supposed to be possible. Okay, let's try the next one. Should this be true or false? True, because they never said both must be. If they said both must be invested in, then we had a problem here. That should be false. Okay, but in this case, they never said it. So true. What about our favorite? True or false? So that's now where we have our false. Yes, very good. Because they said if x2, so if x2 is a 1, then they must invest in x1. So that's not a 1. So that's where I've got a problem. That must be false because that should not be allowed. Okay, now let's play around with our signs. I'm going to start again with less than, even though it's going to obviously be a bit of a problem, but let's see. Is 1 less than or equal to 1 true or false? Whoever's gonna join this chat afterwards is gonna think, what is happening there? True. Is it supposed to be? Yeah, you guys are glitching. Okay, but anyway, is it supposed to be true or false? Yes. Yeah, imagine that, hey. But okay, yes, it is. Okay, so now for the next one, it's very important that you see. Yeah, that's true. But for the next one, is 1 less than or equals to 0? True or false? False, 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 false. Should it be? No. So I cannot use that because even if I continue, it will not work for all the conditions. So yes, then we stop and we try something else. We then eliminate that sign to say that in the middle will not work. So we then go and say, okay, not work, no, no. Let's try something else. Like I said, it's going to be a trial and error until you get something that meets all your conditions. So even those green that I put there is options, things that you can do, right? You can multiply something, not a variable, but with something, a value, like 2, 3, 4, whatever. You can have a plus or a minus in the middle of them and then have the signs later on with some right-hand side value, like 2, 3, 4, 0, 8, I don't know. So it's all trial and error, but mostly it will be very similar if you see a different example, but they also say the same thing, like if this, then this. I mean, is it going to be much different? No. You already know how to do this one, so just do that one. It's just if we bring in something that's not different in terms of wording, now you have to go play around. Okay. So this trial and error just purely based on you're trying to create a constraint that will meet the restriction and not restrict too much. All right. Yeah, so 3 variables, then that's a bit of a fun. But guys, with 3 variables, you have no choice. You can't just put a less than or equals to in between all of them. I mean, you can't make a constraint like this. No, no. Right. So with 3 variables, it will probably be something like either you're going to play around with if they all have just a singular value in terms of if this, then this, not this, or both this, you're going to have the sign between of the both, but for the other one, you will then have to multiply something. So you'll kind of see a pattern if you look for it. So I'm hinting towards look for a pattern. If you see, oh, this is where I do this normally, if we state a question like that, just with obviously different scenario, then kind of that's what you're going to do. Right, I can't obviously tell you exactly what, but I'm hinting towards look for patterns if you feel like you're struggling with this part. Okay. All right, but anyway, that does not work. So now we try the other one next. So let's try now greater than or equals. For the first one, is it true or false? Ah, nice. True or false? True. Should it be? Yes, perfect. Next one, true or false? True. Should it be? Everyone said yes before, but I'm glad you know what I'm going to ask. Yes. Next one, true or false? True, should it be? Yes. Next one, true or false, and should it be? Like Armandre said there. Give me all in one. Mm. Mm. 0 greater than or equals to 1. That looks better. If and yes. If and yes. Right, so 0 is not less, not greater than or equals to. Oh, we're on the fourth one. That was glitching. So not greater than or equals to, so it's false, but it should be false. So perfectly fine. So greater than or equals to actually work for all of them. So we can now write our constraint as x2 greater than or equals to, no. Whoops. Remember, I'm using this now. x1 greater than or equals to x2. How can I rewrite that constraint? Let's see if you guys got that part. Perfect. Take the x2 over. It becomes x1 minus x2. The sign changes. Greater than or equals 0. Now, why is this constraint the same as what we had before? Why is it the same? Thank you. Multiply or divide by -1. When you multiply or divide by -1, the sign flips. Right, so these two are exactly the same. So it's important that when you review that you check that. We normally set it up for the one and then we manually give marks for the other method so that it doesn't mark everything correct, because if you make a mistake on the one, then it's going to mark it as correct. So you have to let us know if you did it the other way around, but it's still correct. Purely just for the less that divide by -1 or multiply by -1. All right. Vian, which one is preferred? Well, can't really say. I guess they're both perfectly fine, but I have seen before that people tend to prefer to say start with x1, x2, x3, x4 in an order of your subscripts going from small to large to, even if it's 2 and 4, just go from small to large so that we stick to the same standard. But it's not a train smash if it's the other way around. Okay. Cool. Monday in your exercises, yes. So it will be part of it, but it's in the exercises, yes. Which I'll then go through with you, but yeah, it is there. Okay, let's look at the next one before you get to your exercise, and then I'll help you with some of the constraints that were tricky, not the whole thing, just with some of them. And then we'll go through Hungarian a bit more, and let's see. All right. Nika, what do you mean with which smallest answer is correct for the test? We make sure we cater for both. So like I explained yesterday, if I start seeing that there are different ways that you can draw your lines, well, that's me. I would stop asking the tables and I would start asking about the optimal solution. So then I'm going to ask just a few tables and then stop asking and then ask for the optimal, so that if you took one iteration versus someone else who took 2 iterations, but you got to the same result, it's still perfectly fine. But it has to be the correct result, obviously. Okay, so we do cater for that. Right. So also remember, that's why I said don't bargain on the fact that, oh, she only asked 2 tables, so there should only be 2. Why do I have 4? Right? No. It's just that's what I asked. Doesn't mean that there's only those amount. Okay. Same as with simplex and dual. Like if I only ask for 2 tables, I won't ask the whole table, of course. I won't ask you to fill in literally every value unless if I need to see every value. So if I only ask 2 tables, don't take it as there should definitely be only 2 tables, right? But I just asked only 2 of them. Okay, just to make it clear, right? Especially if I started doing this, especially for the fact that if something goes wrong, you should not stop. I mean, if let's say I don't have enough tables, you should not stop. I mean, you should get the optimal solution, right? And it also doesn't give away the answer. Sorry about that. I don't want to give away answers. Right. Etienne, I will specify in the test. Right, so if you are in the test and nothing is specified and you are not sure, you can always ask. I can't confirm, obviously, if it isn't feasible. I just mean that's obvious. But I can confirm what you should put in if it doesn't specify. If it does specify, I'm just going to tell you, go read. Right? Or someone else will just tell you, go read. Right? But yeah, we will specify something like, for example, put not applicable in the Z because there's no Z. That's actually feasible, and write infeasible when I ask you to pivot or something like that. We will definitely specify something. Or there will be a drop down saying not possible, infeasible, an option that says that to make sure that you can select the correct option. Okay, so just read very carefully. What should you do if you encounter that? Obviously, if you don't encounter it, don't read, go on, right? But then you encounter infeasible, then you quickly read what did they say about infeasible, or is there an option in the drag and drop or drop down or whatever for that? Okay. All right, let's do number 3, which is a bit larger, and then I'll allow you to attempt this beautiful exercise. I'll give you some hints, but it's a very beautiful exercise because it actually forces you to think a bit about how am I going to set this up. All right, but I'll give you some hints there. But let's do the third one before we get there. Yeah, technically this is all there is. It's only the exercise we included some kind of constraints to do with averages as well, but it's also, I mean, you know what an average is, the sum of everything divided by the number. You know what that is. So it's just logically you putting it in a constraint. Right, so that's technically all there is to capital. You've got inputs and you want to make sure you use all those inputs to maximize the output. That's basically what happens. Rishkar, of course, we can ask you to solve something like this. I mean, I won't ask you to solve this. That's a bit of a big IP to solve in a test, but for an exercise, an assignment, whatever, obviously we can take all of this. It's still an IP. You can use branch amount simplex or cutting plane. We can, however, ask solver because it's a very quick method. All right, so just make sure you go check again how to solve this with solver if you do something like this, because then that's 3 marks, to be honest. Right, but just going back to this one, this I can ask you to solve if purely just this without all the extra stuff, definitely, because it's just like 2 constraints. It's not much you can go wrong with, okay? But those constraints we're very wary of asking you to solve because then it messes up literally everything. So you'll have like a separate question rather. Right, but you should be able to solve it. I'm just saying We'll rather give you separate questions, not so that everything doesn't build on that one mistake you make. Okay. Due to method marking obviously not being applied. So we tend to have an easier IP for branch and bound simplex and cutting plane. Easier, I'm not saying the easiest, I'm saying easier than these logical constraints. So an easier IP so that you can do all of that branch and bound and cutting plane and whatnot. And then separate questions for the more logical type of questions in terms of IPs so that it doesn't build on top of each other. Right, so something like solver would be perfectly fine because it won't count as much as branch and bound simplex, like not nearly enough the same. Right, so I hope that helps with prepping. Okay, let's do number 3. Let's see how that goes. So they say if stocks and bonds invest in investment 2, so X2, they cannot, so 2 cannot do 4. Okay, so investment 2, they cannot invest in investment 4. Right, so 2, they cannot in investment 4. All right, so if we take this, we have to first start with our conditions. So let's see, play a round of combinations. So I'm just going to play a round of combinations, but let's try the first one. Did I really start with this one? True or false? Should it be true or false? Shouldn't have started with this, but anyway, should it be true or false? True, right? Because that's literally what they ask. True. Right, so that must be true. Why? Because they say if 2 is invested, then 4 cannot. So I'll just make it clear there. If 2, then cannot take 4. Okay, so if 2, not 4. Next one. Should this then be allowed? True or false? Very good. That should be false because they clearly say if you invest in 2, you cannot invest in 4. So that must be false. Next one. True or false? What should it be? Awesome. You guys got that previous one. They're only saying if you invest in 2, you cannot invest in 4. But they never said what happens if you don't invest in 2. So don't restrict it. That's nothing to do with that scenario. So don't restrict it. If you restrict too much, you're going to take away possibilities that could have been the best solution. Right, next one. True or false? What should it be based on what I just said? Very good, true, because they never said what to do if not. Okay, now we have to play around. So this one's going to take a bit longer. So I'm going to just start talking a bit faster. So let's start with less than or equals to very quickly. True or false should it be? True or false should it be? So give me the T yes, if yes, or T no, or what? 1 less than or equals to 0 is definitely false. Should it be? No. So immediately I say no, will not work. Okay, next one. Greater than or equals to, I don't know why I selected, but it didn't go orange. Greater than or equals to, will it work for all of them? Let me just ask that. Will it work for all of them? Nope. So just to show if someone's not 100%, right? So we go and say, okay, this one greater than, that is true. So is it supposed to be? Yes. This one greater than, that is true. Is it supposed to be? No, does not work. Okay, so that doesn't work. Will equals work for all of them? No, definitely not. Even the first one, I can immediately see 1 is definitely not equals to 0. So that is going to give us a false, but it's supposed to be true. So no. So now I'm forced to go the other route to say, okay, before I multiply, I first go the next route by saying, I'm going to take the same stuff, but I'm going to then work with a plus or a minus in the middle. Right, so I'm going to have some kind of right-hand side value, and I'm going to work with plus or minus in the middle. Let's play around. Let's see. All right, so it can be plus or minus, whatever makes it work for all of them. And then you're going to have some kind of sign, which you'll decide at the end what to put, and some kind of right-hand side value to make sure everything happens. Right, I just want to... it's okay to have that space. I actually just wanted to make more space, but it's fine. It's going to take too long to do that. Okay, so let's see. So what I normally do, so I'm going to show you what I do. If you find a way that works for you, that's great. I mean, whatever works. As long as you get a constraint that works for all the conditions. All right, so if I use a plus in the middle of all of them, I'm going to quickly check what my totals will be. So I go plus because it has to apply for all of them, whatever you decide on. So I go check. 1 plus 0 is a 1. 1 plus 1 is a 2. 0 plus 1 is a 1. And 0 plus 0 is a 0. Then I go check. Is there a way for me to make sure that everything that is true is included with some sign and some right-hand side value? But exclude, so the false must be excluded. Because if it's excluded, it's not going to be possible. So let me ask you, with what I just said, can I use plus? So can I do something with those signs and the right-hand side to make sure that the true values are included, but the false is excluded? Yes. So do you see, you're not literally playing around there with the signs and the right-hand side. You just think, what am I going to use to include? If there's nothing I can do to include all the ones that are true and exclude all the ones that are false, then I have to try minus. If that doesn't work, then I think about multiplying something. Or divide, because both are the same. I mean, instead of multiplying, you're dividing, and it will work out to be at the end the same. So we're going to say yes. How? What sign and constant will include all the truths? Yeah, you guys are getting there. Right, Andre, just, yeah, I see you correct yourself. Just be careful for that glaze that it doesn't exist, right? So I see you correct yourself before I said it. But it's good that you said that so that I can make it clear to everyone. It must be less than or equals to or greater than or equals to. All right. Okay, so less than or equals to 1 is perfectly fine. Why? Because this is a 1, this is a 1, this is a 0. It will include all of those, but at the same time, not include the false, which is 2. Right? If you went with greater than or equals to 0, it will include literally the false as well. That would not be correct, because then you'll say the 2 there for the false is also included. So then that value will also be allowed, which should not be allowed. The false value should not be allowed at all. So you are trying to get something that with the sign and the number, all the true should be accepted or allowed, but the false ones should not be included. In that way, you'll be able to make sure that the false values are not going to be possible and the true values are going to be possible. So that tells me I can use plus in the middle of x2 and x4. Right, if that was not the case and I tried everything, I'm like, there's nothing I can do to include all the trues and exclude all the false values, then plus will not work in the middle. Then I have to try minus. If that doesn't work, I have to multiply something. Those are your options. Okay. So now we say, okay, but what do I do with checking? Like, how do I check that? We do exactly the same. So we put our constraints now that we said it's going to be less than or equals 1. What you do for the 1, it's going to apply to all, because you can only make one constraint, right? Otherwise, you're going to either not restrict enough, because you're probably going to have to put 4 constraints, which you're not going to do because you're going to forget about something. And that's very inefficient, like extremely. And if I say something, just to make it clear, if I did something like this, greater than or equals to 2 and next 4, less than or equals to 4, it will not restrict them at the same time. Okay, let me say 1 and a 0 or something like that, because it's binary. So it will not actually restrict them at the same time, like making sure if 2, then 4. No, it's just saying always x2 must be greater than 1. So you can't do that. That will not work. Separate constraints, no. And the more constraints you have for something, it could be one constraint, that is seen as inefficient, right? So please take note of what I said. Now let's see and test, see if it works. Okay, 1 plus 0 less than or equals to 1. Is that true or false? So I'm just writing out 1 plus 0 less than or equals to 1. True. Should it be? Yay, so that one's met. Next one. 1 plus 1 less than or equals to 1. True or false? False. Should it be? Yay, so that one's met. Next one. 0 plus 1 less than or equals to 1. True or false? True. Should it be? Yes. Next one. 0 plus 0 less than or equals to 1. True or false, and should it be? True, yes, and yes. Okay, so it meets all my constraints. So I can write my final answer. Remember, if you use a plus, it needs to be for all of them. If you put this in, it needs to apply for all of them, right? Yeah, the most cryptic chat. Okay, so how do I write this? I'm going to write x2 plus, because that's what works, x4, and then less than or equals to 1, because that's what works. And I'm done. It's in standard form as well. Okay, so if you want to take a picture, now's your chance. But the slides are probably okay. If you saw what I did, then it would be okay. All right, but this is going to take some practice, of course, but that's the idea. That's actually all there is to binary constraints. You're playing around with combinations. You're logically thinking what is required, and based on what is required, what should be allowed and what should not be allowed. And then you play around with creating a constraint that makes sure that what should be allowed is actually allowed, what should not be allowed is actually restricted. All right. Yeah, it could be similar. I would more say similar to the exercise, because then there's a bit more body to it. But yeah, similar to this in terms of there's a few binary and then a few other types of constraints, and then which is just logically setting it up without even thinking really binary, to be honest. But and an objective and your sign restriction. So it's very similar to this. It's just the part where you have to apply logic to think what would work. That's the difficult part. right? But it's similar in terms of it will help. The concept is the same. Obviously, I mean, it's the heading. I can't ask you a different concept. Right, but the idea is the same. Logical constraints, trying to apply things to binary specifically. Right, so binary problems right now, binary constraints. Yeah, some of those are mine, some of those are Mr. Welgemoot, and some of those are Mr. Chiteli's, and we even though we change the test, we kind of stick to some nice themes to not make it as boring as it could be. So yeah, you'll see some themes there. Definitely some themes. No, not necessarily. I mean, um, sometimes something you just need a little bit of a something to make your day, you know. And then if only if we ask you to solve, then you'll do you'll solve Z. But no, there's no calculation to Z because it was purely just about the IP itself. This was just setting up the IP. All of this was just adding on constraints to the IP. All right. Armandre, I think I should say it depends on who. Oh, that sounds horrible, but yeah, I'm just kidding. All right, let's see. I'm gonna give you some advice with this one, then a few minutes to try, and then the solution is it should actually be uploaded, but for let's say 2 of them, I'll run through to help you with that, but the rest you'll see in the exercise solution. As long as you're working with me on the chats, yeah, I'm sure I won't laugh if you're crying. Oh yeah, Gandalf's gonna be there again probably in the slides. Yeah. And non-traveling salesman Gandalf is there. Sorry about that. So you'll be seeing Gandalf. Okay. Yeah, fun. Imagine. All right, let's see. Yeah, Santa is now old news. Oh yeah, that's a favorite from us to see what you guys do with something like that. That traffic light was interesting. Yeah, I'm taking notes. I'm sitting in my pen. Okay, guys, just to give you some advice on this one. So again, you've got inputs. In this case, it's just what team members are capable of. That's the inputs that you're working with. And then you want to create the best possible team. All right, so you have to check what are they capable of. So if different players, in this case 7 players, you have to check what are they capable of, and checking what do you want to maximize or minimize, what do you want to restrict, what do you want to demand, and work with that. Okay, now just some advice. Do not go the XIJ route. Don't yes, you're right now seeing a table and you're probably thinking matrix. Not quite. Because if I go and set up just quickly the objective function with you, you'll see what I mean. So not the objective, the decision variables. You'll see what I mean. So if I want to set up a problem to maximize the total defense ability, for example, I need to pick which players to put in the team to maximize the defense, because each player has a value for their defense, right? So in order for me to maximize that, I have to incorporate each value for each player. So am I going to look at saying x1, 2, 3, 4, x1, 5? No, I'm not going to do that, because then I'm going to have a crazy amount of variables that is unnecessary. So the reason being is right now we're just going to specify whether the player, sure, now it's raining really loud, whether the player will actually be chosen or not. And then we're going to look at these separately. So it's not like a matrix where you're saying player one position, player one ball handling, and you can compare it in terms of this is the same thing. All of them are different things that you're going to restrict or demand. So because they're all different, it's very inefficient to create variables that are going to be xij. You're just going to work then with xi, because those are different things and you're going to look at them in different constraints. Okay. If this was like player 1 to 7, how can I put this? Let's say position B, C, B, F, F, C, what, and I put all the positions there. All of this has to do with position. Then I go and say, okay, maybe I can create that kind of xij. All right, but that's only if that was the case for literally all of them. It doesn't mean you have to. I'm just saying you can if it's really going to work as a matrix based on your constraints and your objective function. All right, so right now I want you to think in terms of the objective function and then relate. Right. Anika, it's not always, but it's advised. It's saying in most cases, right? In most cases, if the subject is related, you can try and do the xij, right? In some cases, you'll start doing your objective function and your constraints, and you're going to see, but why am I rewriting this variable with this value over and over? I could have just written it once, because it just applies to one single topic. Right, so you'll see then, oh, I'm doing this over and over in the same constraint. Why? It doesn't matter. And then I'm adding player one more than once, which makes it problematic. So let me show you with, let me take a constraint. Let me show you with a constraint so you can see what I mean. So let me take a constraint, the easiest one, at least. Not that one. The 5-player team lineup must satisfy. Meaning you need a team of how many players? Who can quickly throw that in there? How many players should be in the team? Even though it's not a bullet point. How many players should be in a team? 5. Thank you. So if I work with binary, either selecting the players or not, and I make it xij, I'm going to have to go and say x11 plus x12 plus x13 plus x14 plus x15. Then x21, where all of the top was for player 1. And all of that would be for player 2. Think logically. Will that work to say we need a 5 team of 5? Nope. So the problem with this approach in this specific example is the fact that if you say the player is chosen for position, well, we don't really have a way to work with that right now, but for position 1, you're saying for the position, but what? Right, so if you say x11, what are you going to say? Player 1 and position, but they all have positions. Like, how are you choosing the player based on that? You have to know which position, but not a position. But let's say you don't see that and you anyway go like this. If you choose a player based on a position and based on ball handling and based on shooting and based on tackling, maybe not this one, but more than once based on the, let's say, excellent work they have or the excellent qualities they have, is that counting the player only once? If I do all of that, will it count the player only once? No. It's going to add those two together, and it's all those 4 together. It's going to see, and then maybe I've got this for player 2. Then it's going to say 5 equals 5. It's going to say, yeah, you've got 5 players. Do I? Do I have 5 players with just that example? No. I only have player 1 and 2 that I just used. Right, so that's not accurate in this example. Okay, so using Xij will not work in this example due to the fact that you're then basically counting the player over and over. So having something like Xij, player and position, like you have to base it on a certain criteria. So you can't just say, is a player in a position, yes or no? Yeah, they're going to be. Is a player gonna have ball handling scores? Yeah, they all do. Okay, so it doesn't make sense for this example. If it was something like, how can I say, a matrix form where you actually need to pinpoint which one is for which one. So like we had before with the previous examples, where you say it is a 1 if it is actually matching. So let's say, how can I put this? Player 1 for team 1, player 1 for team 2, player 1 for team 3. So if I say player 1 can be in team 1 but not team 2, then I can use this to say, but where is the player going to be then? It's going to then help me identify player 1 is going to be for team 1 and player 2 is going to be for team 2. If I need to be able to identify which topic there matches with this, which topic here, oh, that's maybe a better way, Annika. Which topic here matches with which topic here, if I need that somehow in the end to be able to identify exactly, is player 1 going to be in team 1? Is player 2 going to be in team 2? Is 4 going to be in 4? If I have to identify it like that, then I need I and J so that I can identify it. But with this one, I'm not asking whether a player is going to be in a position or whether a player is going to be in ball handling. So I can purely set it up as, it's just 1 to 7 players. So let me just go look at the criteria for position and ball handling and so forth. Right, so that could be it. But don't fall for the trap of me writing this differently in a sense. So I've seen in tests before where it could be something like players. So all of this would be there, and then they create a separate one for, let's say, backfield C and B to F. I'm just going to quickly show you an example. So player 1 would then have this. Player 2 would then have this. Player 3 would then have this. So that might be a bit confusing because then you think, oh, I need to see player 1 can do backfield. But you're going to have other players probably that can also do it. So you have to read further into the constraints to see, like, do they really need to see player one in backfield? Or is it just a way of you identifying who can do it? Right, so in the constraints you'll read further on, they'll say something like, we want to make sure that there's at least one backfield. Then you go and say, oh, okay, we just need to identify which people or players can actually play backfield so that we can include them in the constraint specifically for backfield. But I don't need to know which one does backfield because it's clearly there. Don't need to figure it out. So it's still just xi then, still. So just be careful for something like that. But if you need to identify which player will be backfield, so you don't know, meaning you don't even know who to choose from. Like you need to figure out for your decision variable which player will be backfield. So it's part of your decision variable. Then, yeah, ij is important because then your answer, let's say x 1, 5 equals 5, will tell you specifically, okay, player 1 and 5, maybe that was something like, I don't know, forward or something like that. Then you know, okay, it's player 1 and forward, whatever that value would be. Maybe the defense or whatever. So we can then work with the fact that, okay, now this player is actually specifically for that position, right? But if I know it already, it's already given to me, I just have to pick, then that's not going to be the case. I'm just going to have to say, I have players 1 to 7. So let's say, for example, player 1. And based off of my criteria, if I choose that player, I know what the player is capable of. Player 1 is capable of backfield. Then I know, okay, if the player is chosen, well done, backfield is also covered. But that all depends on the constraints. So let's quickly look at one of the constraints there. So the 5 team members. So here you'll see the 5 team members. So you're purely going to say, if I add all of my members together, so literally up until 7, if I add all of them up, I should be able to specify equals to 5. Why? Because then I'm making sure that, remember the binary, I'm making sure that if I add all of those that are selected, all of the team members that are selected, it cannot go more or less than 5 members. So I'm literally counting them up as I'm adding them. Right. So that's the idea, to show, okay, now I can count them up. But if I had x1, 1 and x1, 2, I'm counting player 1 twice, 3 times, 4 times. So I'm not saying it's impossible. I'm just saying it's inefficient because you can set it up a certain way. I'm not going to show you how because then some of you will actually go and do it. But that's the idea. Right. Okay, I'm just going to give you one more piece of advice before you tackle this one. So this constraint and that you'll figure out very quickly. But this constraint and this one, those are going to be your hardest one. This one is not the simple like we did before. You're going to have to multiply with something. Okay, so I'm just giving you a heads up there. For the average one, guys, think about how do you get the average of something and which variables can you use to show the average. And then you set it at least 2. All right, that's as simple as saying that. Average is the total sum over what? You can tell me. Sum over? Total sum over what? What's the average? How do you calculate the average of anything? So the sum of and n, so your number of players, total players, so the number of players, right? So total sum divided by the number of players. Yes, there is an answer for this one. So just checking, they are telling you, that's all I'm going to say. And then you set it They said at least 2. There you go, at least 2. Just obviously don't leave it on that form, guys. You cannot put that in simplex, so I'm not expecting you to give that to me as the IP. Sort that out. How do I sort that out? Kenneth, not everything, no. The solutions are there. You can go through a solution and check it. I'm going to check now what you mean with that, or to check if you're correct. But what do I do to sort that out? Thank you, Tyrone. Yes, you just multiply that right-hand side by whatever n is. Okay, so you simply just say times n, and that's going to cancel out. So it's going to be then on that side that you multiply. Perfect. Okay, so you simply just multiply both sides to actually have it not as a fraction on the left, right? Yeah. I'll go through the average one and the long one in a few minutes to help you with that, because those are the most difficult. And then let's see, Andre, what you said there. So you're saying for the backfield one, you'll have x1, x3, yes, x5, and x7. Yes, 100%, Andre. You've got the idea. Yes. You've got the idea that we're going with here. Very good. All right, but guys, try it on your own before you check any solution. I mean, in a test, you are not given a solution, hey? Like you're given any kind of logical stuff. So you have to be able to think on your feet there, right? This is the purpose of this topic. So I'm going to give you until, let's give you until break, and then after break, I'll go through 2 of them, and then just a quick recap on Hungarian a little bit. Not fully, just a little bit. So I'm going to say do until 10, and then break, then not now, then break 10 till 10:15 like always. Okay. Good luck. Let's see how it goes. Don't look at the answer until you are really sure you need something. Someone asked something that I wanted to talk about everyone. For the assignment, guys, it's up to you. The slides are there. So even if the topic is not done yet, the slides are there. It's a very easy topic, to be honest. So if you want to go try it on your own, you can. But I mean, you have done branch and bound simplex. I have given you a tip how to deal with the binary. The IP is very easy. You can go through the slides there. And then just leave the algorithm itself, the knapsack algorithm itself, you can then leave until we do, right? If you feel like you want to focus on what you know already. So it's up to you if you want to do it now or wait until we do it in class. You have the study guide to see when we will do it. But yeah, my advice is do the IP because it's so easy from the slides. And branch and bound simplex you do now. You know how to do branch and bound simplex. You know how to do cutting plane. And I have told you about that tip, how to deal with binary. So you already have all of that information to do that big part of the assignment. Okay, just based on questions that I've received. All right, I'm going to mute myself first. Okay, good. Let me see this one. All right, so I'm going to just quickly sort out my paint to give me some space to write. I need to just do this. Okay, let's see. Let me help you with some of them. And then obviously we go quickly through one of the Hungarian just to make sure that you get the concept. And then you obviously have some studying to go and do. So let's have a look. So if I just quickly look at least 4 team members must be able to play backfield. So remember your variables are x1 to 7 where either the player is chosen or not. So if you want to set up a constraint specifically for backfield and you want to say at least 4 team members, you want to count up the team members that can actually play backfield. You're not going to add team members that cannot. Otherwise, they can actually be chosen for this position. Right, so remember it's just ones or zeros, so we're counting them up. But who do we count up? So if I go back here, so based on Armandre's question earlier, which players can play backfield or the position? Who knows? Which players are we referring to for B specifically backfield? Perfect. So if you look at this table, it's just simply there to tell you who can. So we've got player 1 who can, player 3 who can, player 5 who can, and player 7. So we're not going to include the other players because it's not possible for them to play that position. So you cannot count them up and then say we restrict or we demand. Right, so you're literally going to then set up a constraint for those because they're the ones that are actually capable of doing it. So you'll then go and say x1 plus x3 plus x5 plus x7. We want at least 4 members. Now, that means you're going to probably have to have all of them just to make it clear there, but that's the constraint that they want, so that's what you put. Now, guys, if you play around with this and you realize that, oh, it's not really feasible, that's not the point. You're not solving right now. You're just setting up a model to solve with. So if you solve and see it's infeasible, well, that was the point. Okay. But right now, it's just to get an IP to handle all of the constraints or restrictions or whatever demands. Okay. So that's where that constraint or those constraints come from. All right, then the average one though. So for the average one, we have to sum all of them together. All right, but now let me see. If I do x1 plus x2 plus x3 plus x4, x5, x6 plus x7 and divide it by the number, would that make sense to get an average? Think about it. Would that make sense? Remember, the variables are only binary. Would that make sense? We've got a 50-50 shot here. Don't be scared to be wrong, but you've got a 50-50 shot. Would that make sense? Would it make sense to work with an average if everything's just 1? Coefficient of 1. If all of them are chosen, what divided by what? If all of them are chosen, what divided by what? Just as an example, not all of them will be chosen. I'm just saying all of them will be chosen. Christian, yes, 7 over 7. So what's the average? 1. Okay, but what's the average? What's the average about? So if I say, is that the average for ball handling? That will not make any sense. Like, how do I know it's for ball handling? That's just the average of the players, like who's chosen over how many players. That doesn't give me the average specifically for ball handling shooting, or tackling. Like, I can't work with just the variables and say divide by the number, because it doesn't give me the average of a specific criteria. Yes, so we have to use the score values, or the coefficients will be the values under the column. Very good. But I want to make it clear that you have to have coefficients for this. Right, very good. Thank you, Annika. Yes, you guys are on it. Right, so going back here, if I want the average for ball handling, I have to actually work with the values to get an average of that. So if I go and say 3 and player 1 is chosen, the value is then going to be 3 times 1, which is 3. If I say player 3 is chosen, 2 times 1 is going to be 2. Then I can actually add all of the chosen players' ball handling scores divided by the number, and I can see what the average score is for ball handling. So that is what we're doing. Okay, so you don't know who's going to be chosen, so you have to include all the scores. So you literally have to go and say, okay, for ball handling specifically, so let me just put my paint like this. So for ball handling specifically, for x1, it is a value of 3. For x2, it's a value of 2. This one, a 3, a 3, and the last one is also 3. I'm just gonna do this, plus a 3. So the values are very important for this, because of course you need the average of that specific criteria. Oh, is it not moving? Thank you, Kenneth. I forgot it does the whole screen thing. There we go. So I just put the values and the coefficients there to show you that you need the coefficients. You can't do that, because that doesn't give you about the specific criteria. So I'll put here criteria question mark to say that doesn't help at all. Right, so this is specifically now for ball handling. Okay. Anika, is there something wrong? Oh, it's showing on a different screen. It's there on a different screen. Let me maybe stop it and share again so that you can see only one screen. Otherwise, it's going to be very weird. Let me do this. That's maybe a bit better. Okay, no problem. Right, so just to show you that top one is not going to work because we don't know what criteria it is for, and it's basically saying the average, but for what? It can't be for ball, because then why is the average the same for ball handling and shooting and everything else? Because it's the same thing. Right, so you have to include the values like this to say, okay, if those players are chosen, for example, if it's this one and this one, that one's not chosen maybe, this one's maybe chosen, this one, and then not that one. What's going to happen is it's going to say 3 times 1 is 3, plus 2 times 0 is 0, 2 times 1 is 2, plus a 1, plus a 3, plus a 3, plus 0. And then obviously we're going to now still divide by the number, but it's going to give you then the total score, or the sum score for ball handling for the chosen players. All right. Then yes, but Armando, be careful. So yes, there are 7 players, but remember they're asking for the score of getting a certain average for a team. That's better. So they want this score to be specifically for the team chosen, because the whole purpose is to choose the best team. So you're going to divide by 5 due to the fact that they said the team should consist of 5 members. All right. So then you can actually get the average. What did they say the average should be? Greater than or less than or equals or what? All of them must be at least 2. So you're then going to say all of that should be greater than or equals to 2. So what do we do with this value of 5? So the value of 5, like Tyrone said earlier on, if you're dividing on this side, you can't leave it as is. So you can either write everything as fractions, which is terrible to write. So please don't do that. Don't punish me to mark your work. I'm going to probably not be lenient after that. So multiply by 5 both sides, please. Okay. Then this 5 will cancel out. I'm wondering, no, don't. Remember, I'm marking your project, so please don't. Then it's just going to be a 10 on this side. So that's what you're going to do for the averages. Hey, I already suffered. I already did my part. It's your turn. Right. Then something else on averages. We were lucky in this case that they told us how big the team will be. Right. So the final constraint will just be all of those values, 3x1 plus 2, greater than or equals to 10. That's your final constraint. Right, so you're just multiplying the bottom to the right-hand side, and that's your final constraint. The constant is still on the right-hand side. Right. Danila, just to give you an example, we do not know what the solution is. Remember, it's a model. I'm just saying if those were the players that were chosen and not chosen, that's how it's going to work. Right, so just explain the ones and zeros there. So for player 1, I said if player 1 was chosen, then that's going to be a 1 because 1 means they are chosen. 0 means they are not chosen. Then I said, okay, if that's the combination for an example, then you literally times the coefficient with that value. And that's where the 3 and the 0 and the 1 comes from. Then you get an actual average. No problem. Right now, we've got a bit of a tricky situation where they might not give you the size of a team it should be. They could give you all of these criteria and then never tell you how big they want the team to actually be. They just want to say, let's pick all the best players based on all this criteria and objective function. Let's pick the best players. Then you might have a team of 6, 7, 5, 4, we don't know. It depends on how many of the best players will fit all the criteria. What do you think we'll do then instead of dividing by 5? What do you think? Instead of dividing by 5, what do you think we should do if we don't know how many players? And Deepa, you're on the right track there. We're going to use a variable, n. So it's still a number of, but a variable. You're close. So how can I represent n, but with the variables that we do have? Yes, well done, Andeepa. Right, that is very good. So x is, if you just simply add all the x's, so xi meaning all the x's together, you're getting the number of. So if they're chosen, they're going to be added together. Even if they're not chosen, they're added as zeros. So to show you what I mean there. So if you do not know how many players, or even if you do, you can still use this method. You would go and say, let me just use this. 3x1 plus 2x2 dot, 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 dot. You write all of them, just saying dot, 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 because it's going to waste time. Greater than x 2. Then instead of dividing by 5, you're actually going to divide by n, which is the number of. How do I get the number of? By using literally the variables as is, because they are binary. I'm going to show you an example. So example again, right? Let's say this one is chosen, this one not, and that one was chosen. It would be the same for the variables at the bottom as well, because you can't have one x is 1 and one x is 0. I mean, your final solution is just one solution, right? So it's going to be the same here at the bottom. So on top, it's going to multiply with the actual scores for ball handling to give you the sum total. So the actual scores. So it's going to be then a 3 plus a 0, because I don't have anything else there, plus a 3. At the bottom, it's going to be a 1 plus a 0 plus a 1. So the bottom, you're just counting the players together technically. You're just saying if they are playing, it's going to be a 1. If they're not chosen for the team, it's going to be a 0. And I mean, adding a 0 is not going to change anything. So all the players that are chosen are going to be 1. That's going to be added together and tell you the number of players that was chosen for the team. So it's going to tell you the team size. Because if those are the players that are chosen throughout all the constraints to meet all the constraints, that's going to be the number size of your team. And on top, you still have the ball handling values for those selected team members. So that's what you need to do if you don't know the size, or if you just feel like you can't remember if the size should be 7 or 5. But you cannot put that in because that's not possible to write as fractions, guys. You cannot say 3x1 over x1. No, that's not mathematically, does not make sense, right? It's literally this over everything at the bottom, and then the 2x2 over everything at the bottom. So please don't go and split them up and be like, oh, that's fractions. No, we now have to follow the route of multiplying both sides, because you can't leave it like that. Like that will not be possible. I just want to move all of that text up so that I can have something to write at the bottom. There we go. And then I'm going to show you what to do. Okay, so right now I can't leave it like that. So I need to take the values or the variables and multiply both sides. So what we're going to do is, let me just see the values. We're going to have our, I'm going to write it out this time, plus 2x2 plus 2x3 plus x4 plus 3x5 plus 3x6 plus 3x7 greater than or equals to. And then on this side, you still have your 2, but you're going to multiply it with whatever was at the bottom on the left. So you're going to multiply it with x1 plus x2 plus x3 dot 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 until x7. Anika, you can't do all of them at the same time. So you're going to have to make separate constraints for forward and a separate constraint for center. Otherwise, if you try to make one constraint with that, you're basically going to just include all of the people, which will not, how can I say, identify who does back and who does forward. If that makes sense. Okay, cool. So usually a key for that would be they sometimes might have obviously different constraints, so different right-hand side values that you have to set them to, which hints towards, okay, they need to be separate constraints. But if that was not the case and they all had the same limitation, you would see it as, okay, I need to limit this, this, and this. But if I go back here and I check, if I put it in perspective of the players, well, if I say player 1 backfield, player 2 center, and I include them both, there's no way of me limiting anything. All right. So that would be quite a pointless constraint, because you'll say everything should be greater than. So It's going to be greater than. Right. Then just going back here. So if you multiply, guys, you're just doing an expansion of brackets where you're just multiplying the 2 in, because that's also not correct. Remember, constant on the right, variables on the left. So you multiply that 2 in, it becomes literally 2x1 plus 2x2 plus blah, 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 2, 2, 2, 2, 2, 2, 2, 2, until the 7. Now, that's obviously not the final step. I have to bring everything to the left. So, like terms. So when I bring this 2x1 over to the left, what happens to the sign? Perfect. Danila, I'm glad you showed that it's 3x1 minus 2x1. So the sign becomes minus, and then you see that it has a like term. So you're going to take the 3x1 and subtract the 2 from that, because the 2 becomes a minus. Perfect. So that's going to then become 1x1. So just specifically for x1. If I look at x2, you take that 2 comes over, it becomes a minus, so it's going to cancel out. So it will be 2x2 minus 2x2, which is going to give you just a 0, and you write 0, right? Okay, let's see. So the final answer would then be 3 minus 2 is a 1. 2 minus 2 is a 0. Don't leave it blank, even though you're used to by now, right? So for chat purposes, leave it blank. But for the test purpose, there you need to put the zeros, because obviously a blank does not tell me that you know what you're doing, right? So zeros are very important to put there, because you're showing that that's literally a value of 0 as a coefficient, right? Then Danila, let me see. 2, and then that's also a 0, yes. And then you said x4, let's see. So x4 is 1 minus, yeah, that looks a little bit better. So 1 minus 2 is going to be a negative 1. So here you can write either a minus or a minus 1, it doesn't matter. Then the next one, x5 is 3, so you minus 1, minus 2, it becomes 1. I gave you the answer by accident. Then minus 2, it becomes a 1. Minus 2, it becomes a 1. Greater than or equals to what, guys? Took everything over, so it's greater than or equals to 0. Okay. That's it for this one. Then you've sorted it out in terms of an average, but without specifying the number of players, because it is not clear or you're not sure. Then you can definitely use this method. We will account for them both. Right. See some people typing, so I'm just giving a chance there. You can try. I don't know if it's going to look that great. Let's see. Let me just go up, scroll up first. Okay, you can try. Hopefully that would be okay. And you can use whatever you do on paper is perfectly fine. So we will ask you for the final constraint. So if you want to, on paper, just say, oh, it's xi, and then just know that you're subtracting 2 everywhere, that's 100%. Just give me the final answer. That is 100%. Cool. Right. Then let's look at that interesting constraint. That beautiful one that we have here. That long one. Just quickly, guys, if it's either or, would both be fine, true or false? Is there anyone who would say true? No one. Okay, cool. I would also say false because if you say either or, it's either or. But that's English, right? We normally say either or is saying either or. That's not possible. However, we are always very skeptical to restrict something if, how can I say, if it's not explicitly specified. So your client doesn't tell you explicitly that 2 should not be allowed, then you ask. But if they don't understand, then you have to obviously try to make it happen. But I would say leave it as a true because it's not clear whether it should be not possible. But I will not have a problem if you making it false, because like if you think of how either or works, it's always a statement of it's either that one or that one, not both, or not none of them, if that makes sense. Right, but yes, Armando, then for the rest, you're going to have the trues as this one or this one. Those will be your trues. This will also be false because this means true either or. Right, just to make it clear that that's either or technically. Right, very good. Let's look at that other one. Caitlin, just let me know if I by accident already clicked somewhere else and you were still taking a photo, a screenshot. Then I can go back. Cool. All right, so let's see. If player 1 starts, then player 4 and player 5 must. They must. So we're basically saying they must be in the team there. Why did it say the then? Okay, let's see. So they must, if that one. So the keyword is if they don't restrict something that is not clear. So let's see. Now this one has 3 variables, so it's not going to be as simple as having just something in between them. Now the tricky one between this is you're probably going to have to multiply something if there's 3 variables. Not always, I'm just saying most probably. Most probably. Now there's multiple ways of doing this one. So the one way is quite of, yeah, it's something else. But I always keep the 2 that are, how can I say, together. We're saying them both must, or them neither must, or none of them. Those them that are together, I keep close by so that I can know what to do with them at the same time or not at the same time. So I keep them together. Now the one that is the if will normally, so I'm giving you a pattern here. I'm not saying always, but normally you'll have to multiply this by the number of variables that are compared to it. So there are 2 variables compared to it, so you'll probably multiply it with a 2. Right? I'm not saying definite, I'm just saying that's something that might help you to first check if that could be it before doing the whole trial and error. Right, so we're saying x4 and x5 must, so you put them together and saying, but what are they based off of? What's the if? What's the condition for them? They are based off of what happens to x1. So x1 is going to get a multiplication to make the constraint work. Then I'm going to play around in between them with a plus or a minus in between them and some sign here to make it work. Right, so it's a very big trial and error. So you can try this trial and error way. I just have a different way that I use with this specific 3 variable example. You can technically do it with 4 if you see what I do. But guys, it's trial and error. You literally go and say, if x1, then these 2 is a must. That must be true. If x1, That possibility should be false because they're saying if x1, both must. Both must. If x1, this is going to be false. If x1, this is going to be false. But I have to check every condition. So what if x1 is 0? Then also the same conditions need to be checked. Exactly true. All of those will be true afterwards. All right, so then you're going to have this, because they never said anything, what if x1 does not get chosen? Right, so all of those true because you don't want to restrict it. But above, you just want to make sure that if x1 is chosen, then x4 and x5 is also chosen at the same time. Right. Now, just to make it clear that you can't do the following. So I have seen this before where students go and say this. That's pointless, right? You're basically saying all of them must be chosen. Here you're saying that all of them must be chosen. That is not true. We didn't say all of them must be chosen. It says if x1 is chosen. So if x1 is not chosen, you can't get that value. Now you say, but okay, then let's make it less than or equals to 3. Okay, but then it's going to allow literally everything. It's even going to allow it to be a 0 and a 1, 1. Because 0 plus 1 plus 1 is 2, and 2 is less than or equals to 3. But we said if x1 is chosen, then those two must be chosen. So this is not, no, a big no there. All right. So you'll play around with these combinations, but remember what you do for the 1, you literally do for them all. If you decide to put a less than, you do it for all. If you put a plus, you do it for all. Now you know by now that I would say go and do the plus or the minus first and see if you can get some sign and take this as now your kind of your right-hand side to make all the trues included and all the falses excluded. Okay. Armandre, using the x1 as a 1, are you sure that would work for everything? If it's just a 1? Are you sure that would work for everything? Yeah, it will be a 2x1. Okay, yeah, no. So it has to be multiplied with something to be able to make this one happen, right? Because you're basically saying 2 of these variables are dependent on this one variable. So you're going to have to multiply that one variable by the amount. So if there were 3 of them, you'll multiply it by 3. Right. I hope that pattern helps a bit. If you want to do it a different way, it's not a foolproof way though, but it could work. And it's a quick way if you feel in a test, I really don't have time and I just want to at least try it. Is a way where you go and say both of them are based off of x1. So I can first start by saying x1 and x4, and then later on x1 and x5, because both of them will be based off of x1. So then you go and say, okay, if x1 starts, x4 must start. If x1 starts and x4 does not start, that should be false. If this one does not start, well, then it doesn't matter what happens to the other one. It really doesn't matter. That should be true. What applies to this will apply exactly to this as well, because it's the same thing. Both of them must start. So you play around with this and find a constraint. So I just want to show you what to do with that constraint. So we go and say, okay, what if we use less than or equals to? 1 less than or equals to 1 is true. Check. 1 less than or equals to 0 is false. Yeah, check. 0 less than or equals 0 is true, check. 0 less than or equals 1 is true, check. So that works. I can create the constraint x1 less than or equals to x4. On that side, it's going to be exactly the same except for x5. Now, I can't work with just two constraints separately, guys, because it will not make sure that they both are chosen for x1. This is just to first start off with the idea, and then we merge them into one constraint. But you cannot leave it as two constraints because it's just checking for x1 and x4, and then separately for x1 and x5, not for x1 and them both. And that will not work for that. Not all your conditions will be met. So you then merge. So how do I merge? They have the same sign. They must have the same sign, otherwise you can't merge them. On the left, it's x1 plus x1. It's going to give you 2x1. On the right, not like terms, it's positive x4 and a positive x5. Yeah. And it gives you exactly the same constraint as you would have if we'd done the long route and we went 2x1 less than or equals to x4 plus x5. Exactly the same constraint. However, the longer way is much better because you are 100% sure the constraint works for all conditions. On the right-hand side, you're not too sure. You just work with half of it. So if it works for both, that you'll have to test. So it's not a foolproof method, but it works. If you don't remember or don't have time, you can quickly use that shortcut. All right. Now, what's the final constraint, guys? Final constraint, because I can't leave it like that. What's the final constraint? Well done. So you take the rest over to the left, they become minus. So your final constraint, I'll just write it in blue because I don't have space to the bottom, is then going to be a 2x1 minus x4 minus x5 less than or equals to 0. And that's your final constraint. Right. If you want to take a picture, you're more than welcome to. I'm going to close all of this, so more than welcome to take a picture or screenshot. But those were the difficult ones with the constraints, but I hope it helped you a bit. But like I said, it's a few marks of these, whereas you know by now, branch amount simplex is a lot of work, so there's going to be a lot of marks. Hungarian algorithm, a lot of marks there. A few marks for cutting pain because usually it's not that long. And then a few marks obviously for an IP like this. So, but those could be the marks that make you pass. So I'm not saying to ignore them completely. I'm just saying it's not a train smash if you don't get all of them correct. At least you can get some marks somewhere else, right? Yes, this would be one of the logical ones. Yes. And just from experience, that's the kind of weights that you can deal with. I wouldn't say necessarily the most, but branch and bound simplex does take a lot of work, so it's going to be probably a higher weight than something like this. Hungarian, it depends on how many iterations there are and how big of a table we give you, but it's also going to be a bigger weight than this, but not maybe the most, but a bigger weight. Right. Can't tell you the exact rates. That's no. The ones you won't study everything. Right. Marizon. If it's me who's going to set it up, so if I am here on time and not someone else has, if no one else has to do it, I'm going to set it up to show your mark. Yes. Andre doesn't matter who sets up the test. Different tests are set by different people. I can tell you which ones I set. You can see it in the text. I just want to open the Hungarian one. Oh, shame. Okay, no problem. Yeah, some of us will take the biltong and not say anything in terms of helping. It's like, thank you for the present. I hope, I assume you did not try to bribe me just now. Vian, we have not fully decided yet. So far, it's 2 hours, but it could be 2.5. All right, so I can't say exactly how long. Definitely not more than 3. That I can tell you. Right? Yeah, sitting here for more than 3 hours would be quite rough. Exams, though, are usually a bit longer, but we don't go more than 3 hours. Right? Yeah, Christy, exactly. Okay, so I just want to show you here that for some of these IP answers, you can see that you can actually solve it with Solver, hey. So if I ask you to give the solution and I don't tell you how to solve and there's no assessment queue steps to fill in, I mean, use Solver. Give me the answers through Solver. And that's just to help you remember how to do Solver. I'm not going to do it. I mean, you can just check how to set up the constraints, how to put in the values, and Solver is literally just clicking and clicking. All right, so getting back to this, they'll probably ask you for an IP. So make sure you understand why there are some stuff missing. But remember, I told you in a test, don't leave it blank. Read the instruction on what to fill in for what kind of scenarios. And like for the capital we had just now, it makes sense to use 0 if it is blank. Right, it makes sense to put a 0 because then 0 times whatever is going to stay 0 and it's not going to be actually added together. Same with these. If I put a 0x22 here, which is literally this dash, I am saying that that value will not be added to whatever values are 1s. Maybe these are 1s and 1s and 1s. That value will not be added to the constraint, which is obviously those 3 1s are not possible with our limitation, but I'm just saying that will not be added at all. The 0 times whatever is put in there, if it's a 1 or a 0, 0 is going to stay 0. So it's not going to be used. But in your objective function, remember we had that whole discussion of for a max problem, you don't want the largest value because you want to stay away from that dash. That is not possible. So you choose the smallest, so like a very small number far away from your values. For a min, you choose something very high, far away from the values, right? Just to make that part very clear. And then read carefully. I mean, we don't have to put a dash. I can just tell you that that job and that person is a no. And I can tell you that that person can't do that job, so don't assign them. So put a dash yourself. So just to make that clear, I don't have to put a dash. I mean, it's not like in real life someone's going to give you a table with a dash in and say, solve. Right? You can have to know what that dash means. All right. So going on, how do you solve? So just to discuss one of this, but you'll see there I put in an extra if it was a max, and all of the examples there. Is it this one I wanted to look at? Maybe. Let's see. Yeah, we could probably do this one. Let me just go to the question. So I don't have the question open currently, so I just want to go and put that in. I've added all of these extra constraints to the previous one so that you have more to practice. It's in the answers, but more to practice for the logical stuff to be ready for tomorrow. Okay, I'm going to close this one. All right. And then I'm just going to open task assignment. So this one, let's see. 4 and 5, yes, that's this one. Right, so we're talking about taking bids on the city's 4 school bus routes. All companies have made bids in the table. So it's assigned to routes. So you can already hear it's a kind of an assignment problem. You want to assign bidders to only one route. So you could already identify that for each bidder. So the company for each of them. So I'm just going to highlight this for now. So for each of them, when you set up the constraints, you need Xij because you need to know if company 1 bids on route 1 or route 2 or route 3 or route 4, I need to be able to limit those choices, hear me say choices, Xij, choices to only one. So I have to limit that to only one. Then the question is, okay, what sign am I going to use? So if I limit each of them to only one route, now I have to check in terms of tasks, or in our case, routes. Do we have enough routes for every company? Do we have enough routes for every company? Yes, we do. So in that case, we are able to say only one. But we have to think first in terms of, let's set up our constraints for our routes as well to make sure that it stays equals. Okay. So let's see, do they say anything else? Blah, 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 blah. Suppose only one route, formulate to minimize the costs. Solve. Okay, then we added a different example. So if that's it, then we're assuming, let me just use a different color. Then we're assuming that this is going to be equals to 1 because there are enough companies. This is going to be equals to 1, this is going to be equals to 1, and this is going to be equals to 1. We're assuming that's possible. And if that's the case, we have to choose one company for each. So if we look at the other way around, equals is important because we have to choose then one for each. It's a square matrix, everything's equal, so it has to be. Not a big problem if you use less than for this because the equals would have already forced them anyway. So like our example in the first slide, there I would have said arguing for this would be okay. Not always, just for this. Now let's go back to say, but what if we use that bullet point where I try to make the example different, which I'm rather going to do. So let's go back to this. So if we get to this stage, we say, suppose that each company can be assigned 2 routes. Each company can be assigned 2 roots. Not must, first of all. Can be, so you're thinking in terms of less than or equals to right now, can be assigned 2 roots. So you're thinking can be, doesn't mean that they have to. They don't have to be assigned to a root, or they can be assigned to 1 root, or they can be assigned to 2 roots. Right. But you can't say 3 roots. They can be assigned to 2, but not more, if that makes sense. So we're going to set 2 here. They're saying each company, so it's going to be applied for each of them. Obviously read, not necessarily. Then we go and say something else. Can be assigned 2 roots, nothing else. So on the other side of life, in our case, our roots, we are going to say, okay, the roots must be bidded on. So I'm going to make it sure it gets at least 1 company to bid on it. Now, will making it equals to 2 for the companies work? Will making equals 2 for the companies work based off of everything you see now? You guys still there? Will it work? No. Thank you, Christian. No, no, no. Okay, so if we restrict it to equals to 2, we are saying each of those companies need to bid on 2 routes. Right, so it's not possible. We don't have 2, 4, 6, 8 routes to bid on. And they can't bid on the same route. We said the routes are assuming to be equals to 1. So you can't have this one and this one, which would then be able to be equals to 2 if you had 2 and a 2 and a 2. That would make sense if it's possible to have more than that. But it's only equals to 1 for each route. So you only have 4 routes. So you can't have the companies, each company bidding on 2. You only have 4 of them. So 2 plus 2 plus 2 plus 2, only 4. All right, so yes, Anika, you're going to have to use less than or equals to 2 to say, okay, we only have 4, so not all of them will bid 2. But if they were chosen, they can. Okay, saying they can. We don't assume which ones because we don't know the solution. It's all about setting it up. Right, now keep this in mind. The IP you can do on your own. I'm not going to do the IP with you. It's purely putting in the values for the objective and setting up these constraints that I just showed you now. It's literally position row 1, column 1 is company 1, route 1. Is it included for that constraint? Yes, then write it. If not, then don't write it, put a 0 if we force you to. Okay, so we go on and say let's solve. So solving this, let me get Excel open. Let me just close that one. So I'm just going to copy this. You'll see I just didn't work in thousands. So at the end, just remember to multiply back 1,000. Right. So that's our values. Put the dashes where they're supposed to be to make sure that that's not possible. Right. So you keep on removing them or leave them blank and make sure they stay blank forever. All right. Okay, let me see. So what's our first step? Who remembers? Row reduction. Yes, 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 yes. Row reduction. That's excellent. So row reduction first. So let's quickly do that. Oh, why did my tab not close? Wrong one. There you go. Row reduction. So we're going to work with each row first and then reduce with the smallest value. All right. So let me copy and paste this. So row reduction first. Row reduction. If I say reduction, you know reduction. Row reduction first. Okay, so we go and say, okay, in the first row, the smallest value is 4. So we go and subtract 4 from everything in the row, except the dashes, because why? They don't exist for us. They're not possible. So just to show you that is subtracted by 4. Exactly, it's not included, right? So the next row is a nice one. Hey, we're going to have a bunch of zeros there because 4 minus 4 and 4 minus 4. In the next row, the smallest is a 2. So 3 minus 2 is 1, and that becomes a 0. In the next one, that becomes 0, and that becomes a 1. Such a nice table. Now, quickly with your eyes, without doing anything, would you say the least amount of lines to cover all the zeros will equals the matrix? Oh, sorry. Three lines. Yes, there's a possibility of 3 lines. Right, so remember to play around with that whole, okay, there's 1 there, 2 there, 1 there. This side, 1, 2, 1, 1. So I'm going to focus on either of these first. So I would have gone with this, then the 2 is out. Cancels out these 2. It gives me, oh no, that one is an undo. Leaves me with that one. So then I'm going to go and do that one. Okay, so that's out. Oh, yes, Caitlin, sorry. You have to do column, but it won't make a difference. Thank you, Caitlin, yes. So guys, column you have to do, yes, yes, yes. It just didn't make a difference though. You can tell me why not to make it clear. You can tell me why it doesn't make a difference. Thank you, very good. So in each column, the smallest value is 0. So the table will stay exactly the same. Perfect. Guys, in a test, of course, like I can't assume it's gonna stay the same. So if we ask for the next values, you have to fill in the values, right? But in a lot of cases, we only ask what will happen after both of these checks were done. So you had to know which order and do it in the right order to get the right values, and then you fill in the values after that. Okay. Let's see, that leaves me with nothing here and nothing here. So I'm left with 1, 1. I'm going to do this. There we go. Then all of those zeros are covered with 3 lines. The 3 not equals to 4 telling me it's not optimal. Okay, now we have to do that whole plussing and the minusing. So we call it either increasing or reducing values or pivoting or iteration. We're doing now an iteration. That's basically it. So for iteration, let me show you. So where they cross, you're going to add. I just want to move it like this so that you can see the dash. Okay, so where they cross, they add. But if it's a dash, what do we do? If it's a dash, what do we do? Nothing. Very good. Nothing. I like the question mark, but you are correct. Nothing. The dash stays a dash, guys. Please do not do anything with them, because if you later on then pivot on it, it's incorrect because it's not possible. If you choose a 0, it's incorrect. If you increase it, well, then you're probably never going to get an optimal table because you'll be increasing stuff that's not even supposed to be used. All right. If you want to get in real life, I'm not saying in the examples, in real life, if you want to include that person for the job because maybe the person can go for training or something, yeah, then leave the person in and then have 2 solutions to show what would happen if we leave the person in and what would happen if we keep them out. So that if the solution with the person in is better, we might need to send that person for training. Right, so I'm just giving you a real life example, but obviously in our examples, if they can't do the job, they can't do the job. No, leave them out. Okay, in this case, if they can't do the bid, they can't do the bid. Right, so now we go on. We say, okay, what do? We add only nothing. Nothing is added, but we do subtract. So where it's uncovered, so all of the uncovered areas, we pick the smallest value, which is only 1. But hear me say the smallest value. It's not always the same value. The smallest value we pick, which in our case is 1, and then we subtract it from everything that's uncovered, which is in our case just that 1 and that 1. So we can make them 0. And then with everything that's covered with 1 line, it stays, not that one, sorry. It stays the same. Everything that's covered by 1 line stays the same. Everything that has a cross, you add with that small value. But we saw now their dashes, leave them out. Okay, try to see if it's optimal or not. Can we get, what's the least amount of lines to cover all the zeros? Cool, table optimal, 4, 4, 4, 4, 4. So no matter what you try to do, you'll see you go these two, oh, but I still have that one. It doesn't matter if I do like this or this. It doesn't matter if I try this, and then this one. 4 is going to be the least amount. So our table is definitely optimal. Okay, if it was not, you do the same steps again with saying where they are crossed, we add the smallest value of that table, right? The uncovered values, we subtract that value from it. The values that are covered by 1 line, we leave it as is. Right, so same steps apply if it was not optimal. Okay, but it is. So now let's go copy the initial table to just have something next to it. Now the logical part comes in where you have to say, okay, what was our constraints, or what was possible, what was not possible. So in the beginning, I showed you that we're working with less than or equals to 2 there for these, less than or equals to 2, less than or equals to 2. That's what I do to help myself remember what's possible here. But I still think logically about it. So we go and focus now on that. Okay, so let's look at our zeros. So we say, okay, in the first bid, there's only one option. So I have to select that one. So company 1, route 1. They bid on route 1. Then if I look at the rest of the routes, there's multiple options. Now, who can tell me why am I also saying this is an option, this 0 here at company 1, route 2? Why am I saying that's also still an option? Why did I not cancel it out? Yes, it can be 2. Very good. It can be 2. So we said there on the side, it can be 2. So I can't eliminate it. If you said equals 1, then you already chose 1 and you'll say gone. Right, but if it's possible to have 2, then you can't eliminate that one. So very good with that. Okay, so don't eliminate. It's still possible. Okay, I didn't choose it. I'm just saying it's possible. But I didn't choose it. Okay. Now let's go back. All right, so if I look for the other way around now, because I have so many possibilities, I'm going to now rather look the other way around. Let's see. If I look from this way around, company 1 can do 2. So I've got 2 options where 1 is already selected. Okay. If I look at company 2, 2 options, none selected. Company 3, there's only 1 option. So I'm going to select that. Company 4. Now would company 4 still have 2 options if I select that one in company 3? Would company 4 still have it? No, because remember that column can only be 1, so that 0 will then be eliminated. Okay, I hope that makes sense. All right. Okay, so now we have a bit of leniency here because we still have some options of taking now this one. So let me now use a different. So we can now go do this one. And, oh no, we don't have an option there. Which one should company 4 choose? That one now. No option. Then we go and we say that one, which then gives me a bit of a choice. All right. But I'm going to tell you something now very soon. I'm just going back here. Yeah, it can be 2. That one can be 2. So we have... Oh, sorry. I had to eliminate that one. Whoopsie. We chose that one. We eliminate that one. Okay, so there's that option. So here we've got options now. Okay, but I'm going to show you now something else to just put your logic there as well. That's if you now go and say we have to choose, we have to choose, we have to choose. But that's not necessarily the case. I'm going to tell you now what I mean there. Anika, not necessarily. There could be 2 answers, and then I'll ask you probably for an alternative solution. Remember, what's an alternative is your Z will give you the same answer, but then you're going to have just different selections. Then I'll be looking for both of them eventually. Right, but Caitlin, yes, that's where I'm going with. If this was the route we took, then you are now left at choosing between these 2. So you then look at the actual table, and because you want to minimize, you're going to then choose the one of the smallest cost. So definitely that would be your route. However, I just wanted to show you this in order to get to this step, to show you that in some cases you're going to now have to go and do this. But let me undo and show you something. So I just want to start from the beginning so that we don't get lost there. Okay, so the first one is 1. That's a definite. There's no choice there. So company 1, route 1, no choice. But our problem that I had with the other side of it. So if we go to company 3 and we choose this one, does it have to be chosen? Who can tell me? Does it have to be chosen? Very good if you identified it from the beginning. But it does not have to be chosen, guys. We said company 3 can be less than or equals to 2 because we can have other companies rather take that task. In this case, if I look, take that task as well, and this one if necessary. So we can't really take that one. So we're a bit stuck there. So this one has quite a lot of variations, just due to the fact, guys, that there's literally zeros for everything except one of them. And we have so many possibilities with the less than or equals to 2 and the less than or equals to 2. So you could literally play around with now looking at the final table to say, okay, as long as I just have 2 in a row and 1 in a column, I get the best values. Right, so this is not usually what we ask in a test because obviously we don't want too many answers to be possible, but you need to be able to identify it in a sense like a smaller, not a smaller table, I mean like 1 or 2 of them will have a bit of leniency that you can look at values. All right, but just to make it clear that the reason why we have this is because, I mean, you could have this chosen and something like this. You could have, instead of that one, said, let's take these 2 instead of that. We could have, instead of, I don't know, this one, choose that one. So there's quite a variation of possibilities with this, just due to that. So you would be playing around with what is definite, and that you'll definitely include then because that was a definite. That one was really a definite. And then you'll be playing around with what of these will make sure that I get the smallest min value by making sure that these are definitely equals 1 at least chosen. So who can tell me which companies will do which jobs based on having this 4 in and then choosing 1 at each column? What would be the best? And let's see if that makes sense. Yes, I can. Company 1. Are we going to say, yeah, let's say R1, because that's the one that was definite. That was the only choice there in that column. Right, only choice there in that column. Then that one, 2, 2, then that one, and then that one. I'm just checking Henry's answer as well there. 2, 2, 3, 3, and a 2, 4. Perfect. So the one that was no choice was this one, and the others you check the zeros where you can possibly choose from. Then you look at your table and say choose the smallest values. Right, so that's going to be a 12, 14, a Z of 14. Very good. Right, what else here? Let me think. I told you about alternative solutions can be possible if there's multiple choices. Here there's no alternative. You select something else, you're going to get higher values. Yes, if you maximize, you'll just choose the largest values instead. Yes, yes, yes. Yeah, this is basically it. Yeah, those are the different ones. For min problem, 14 is then the the one that you would specify. Perfect. Perfect, perfect. But if it is max, then 17 would be the one, yes. In this case, yes. In this case, yes, because you weren't limited in terms of the companies. There were only 2 for each company, and well, you had tasks that could be for more. Usually here, either you're going to use the values to check, or you're going to have some kind of priority list to say which ones are preferred. I'm not saying necessarily in a test, I'm just saying then you'll have to ask questions like, okay, which ones are, let's say, more valuable to do than others in terms of other aspects or other factors, right? Or you just say what would be the best in terms of the costs. Then you do what we did just now by playing around with the zeros that are possible. But take note, guys, I didn't even consider that one here. I didn't even consider that here. That was not a consideration because it was not a zero. All right. So just to make it clear, that was not a consideration. Okay, that's it. I hope this helped a little bit with the practicing. How do you guys feel with Hungarian? Better. Okay, that's good to hear. That's much better. In the solution, I just followed that route of trying to kind of force them. So meaning kind of forcing all companies to at least have something. So if you're trying to force companies to at least have something like we did with the people, because logically speaking, if you have agents that need to do tasks, I mean, you don't want someone doing nothing. However, for the company with the bid one, it was a bit arguable because, I mean, do they have to bid on one? Do they have to? Do they have to bid on a route? So there it was a bit arguable to say, okay, you could have either gone this route by saying, okay, I have to at least make sure a company has one. I have to at least make sure they have one. So just to show you here, so instead of having a free for all, we would have done the first steps that I took, where I said, okay, this one has no choice. There's only 1 0 there that I can choose. Then I eliminate the other one because I want to force all of them at least to have one. So then I choose this one, I eliminate the other one, I choose this one, I eliminate the other one, I choose this one. Because I want to force them all to at least have one. All right, so that could be an argument to say we normally force them all, so let's force them all. And then the Z would have been 15. But logically, you can argue and say, no, but nowhere they stated that they have to bid on a route. So this method for me would have made more sense. All right. I hope that makes sense. It's only this part that's very difficult, but before that, it's literally getting the first table, row reduction, column reduction, doing the optimality check, so conditional check, just to make the wording clear, conditional check there, and then actually doing the iteration where you add, subtract, or increase and reduce, and then leave the same, whatever should be left the same, until you get the optimal solution. Once you get there, that's obviously the tricky part, but it's at least not the most of it. Right, and you can, like I showed you here, if you have time, only if you have time, don't waste time. I'm saying only if, then you can do this to check if your answer is actually correct, if you had the correct zeros that you chose. Right, but I'm saying only if. And please take note of solver, we want them to be binary, so you would literally go and specify that the answers there should be, as you can see, the constraint that I've added there should actually be binary. So you're going to go and specify, I want it to be bin. Okay, just to make it clear. All right. But yeah, I hope it's going to go well tomorrow. Let's hope for the best. You can now just practice a bit. But yeah, you've got the study guide. Sorry for those asking me privately. You've got the study guide, guys. Please check the study guide for what will be in the test if you're not sure, especially if you missed class, because I know it's been up and down for some of you. Check the study guide. Make sure you know which topics to go through for the test. But everything we covered this week, yes, up until what we did till now. All right. Yeah, for this week. So it's quite a lot. So you have some studying to do and some practicing. So I'll let you do that now. And you can send private messages until about 5 minutes to 12 if you need something. But then otherwise, test tomorrow, webcam, very important. Be on HypeFlex before 8 with your webcam on. Be ready. Make sure you sign into assessment queue. Get ready. As soon as it's 8 o'clock and you don't see that test, you tell us. But guys, if you don't see your assignment now, you won't see the test. So don't let me know tomorrow that you don't see it because you didn't see anything. Right? You can already go check if you see your assignment. Please. If you see your assignment, then you'll be in the groups. Right? Then you can let me know if you're still not. Please. Okay. All right. Then you probably saw, I see now someone asking. You probably saw, so sorry guys, I've sent private messages and I think it will help others. I just say it for everyone. So it's not to be funny. But if you have members that are inactive for your project, because I know there are some members that probably decide they're not going to do it this year or whatever, but we're not aware of it. And so just please try and contact them on different platforms. So try on Moodle with the chat option there, because that's how you probably saw who's your group members. So if you didn't know, you go to the chat in Moodle and look for groups there. Then you can see who's in your group for the project. But you can look for your group members there, send them a message on Teams. Then on Teams, you check their email and you send them an email. Cover all your bases to make sure you reach that person. If that person still doesn't respond, I don't know, by week 2, do it yourself, okay? Like I said there in instructions, you'll have to pick up, but keep those screenshots so that you can then send it through with your project so that person does not get the mark that just to make it clear. So continue with. But I would say if the project has some pieces you can leave open just in case someone wakes up in the last week and you still have time to do it. If they don't, do that. Right? So try to be inclusive if you can, but yeah, don't punish yourself. If you need to continue, you continue. If they then can provide you with other means to make the project even better, but they just woke up late, great, include them. Right. I hope that helps. Any other questions? If I unmute, then I'll probably tell everyone. So please don't leave until 5 minutes to, but you can do your own thing and exercise, but please don't leave just in case I have to say something to everyone that maybe applies to everyone. Okay. Guys, recording, someone did say something about it somewhere, but yeah, I was informed that there are no recordings, but I see it recording, so I don't know. From my side, I don't know about recordings. If you find it, great for you. Christy, yes, Laubscher. That's my surname. Oh, yeah, they still have my original Skooma. So you can use Skooma there. Right. I'm gonna mute myself and only unmute if I have to answer some questions. All right. So stay until 5 minutes 2 or so. But otherwise, other than that, I'll see you tomorrow for the test and good luck.